spectral lines of H atom. We know that energy of electron is given by En equal to minus 2 pi square mk square z square e power 4 divided by n square h square. But before that, let's see how. So we know that kinetic energy of electron is given by kze square divided by 2r, and potential energy is given by minus kze square divided by r. So sum of the two will give total energy. So let's write total energy as En. So this will become minus kze square divided by 2r. And we know that radius is given by n square h square divided by 4 pi square mk times ze square. Now, if we put this value of r here, we will get energy as En equal to minus kze square divided by 2 times n square h square times 4 pi square mk ze square. So it will become minus 2 pi square times mk square times z square e power 4 divided by n square h square. Now, if electron makes transition from one level to another energy level, in that case, photons are emitted, and the energy of emitted photon will be given by h nu equal to difference of energy of the two levels. Suppose we denote it En2 minus En1. So this will be equal to, here this n we can take common in the two cases, and then other things will remain same. So 2 pi square mk square, and for hydrogen atom z equal to 1, so e power 4 divided by h square times 1 upon n1 square minus 1 upon n2 square. Now, here this is h nu, and if we want to find out nu, in that case we divide by h. So this h will become h cube. So 2 pi square mk square e power 4 divided by h cube times 1 upon n1 square minus 1 upon n2 square. Now we know that C equal to nu lambda. So nu can be replaced by C upon lambda. So here, if we write it C upon lambda, and then we divide each term by C. So we will get 1 upon lambda, which is also written as nu bar, called wave number. It will be equal to, here we are dividing each term by C. So this will become 2 pi square mk square e power 4 divided by ch cube times 1 upon n1 square minus 1 upon n2 square. Here this term is called Rydberg constant, whose value is, this is written as R, and its value is around 1.0973 into 10 to the power 7 meter power minus 1. So our expression of 1 upon lambda r nu bar becomes r times 1 upon n1 square minus 1 upon n2 square. Now we are going to see different types of spectral series and their transitions. So let's see. So here, suppose first orbit is this is second orbit, this is third orbit, and there is transition from second to first, from third to first. Similarly, there are other orbits. Let's draw it properly. So suppose this is first orbit, then there is suppose second orbit, and suppose this is second orbit. Similarly, there is third orbit. This is third orbit. Then let's consider fourth orbit. So then next orbit like this. Now let's consider the transitions. Suppose transition is taking place on first orbit from higher levels. This is for first orbit n equal to 1. So here transition is like this. So this transition. So transition is taking on n equal to 1 from n equal to 2, 3, 4, etc. So such a series is called Lyman series. So we write it nu bar equal to 1 upon lambda, which is equal to r times here 1 upon 1 square minus 1 upon n2 square, and n2 square, here n2 can be 2, 3, 4, 5, etc. So this is Lyman series, and this series lies in ultraviolet region, UV region. You have to memorize the region also, in which region the series lies. Now consider next one. Suppose transition is occurring on n equal to 2, means second level we consider. So here third to second, fourth to second, fifth to second. So this series is called Balmer series. So we write nu bar equal to 1 upon lambda equal to r times 1 upon 2 square minus 1 upon n2 square, where n2 will be equal to 3, 4, 5, etc. And this series lies in visible region. Now consider next series when transition is taking place on third orbit from fourth, fifth, sixth. So here n1 will be 3 and n2 will be 4, 5, 6, etc. So such a series is called Austen series. So we write nu bar, which is 1 upon lambda equal to r times 1 upon 3 square minus 1 upon n2 square, where n2 equal to 4, 5, 6, etc. And this series lies in infrared region, IR region. Now consider next series. If n if n1 equal to 4 and n2 equal to 5, 6, 7, etc. So if n1 equal to 4, n2 equal to 5, 6, 7, etc. In that case, series is called bracket series. So we write nu bar equal to 1 upon lambda equal to r times 1 upon 4 square minus 1 upon n2 square, where n2 will be equal to 5, 6, 7, etc. Next series is, this series lies in IR, infrared region. Now suppose n1 becomes 5. If n1 equal to 5 and n2 equal to 6, 7, etc., then series is called Fund series. And we write it 1 upon lambda equals nu bar equal to r times 1 upon 5 square minus 1 upon n2 square, where n2 equal to 6, 7, 8, etc. So this series is Fund series, and this series lies in IR region. Thank you for watching.